Smart Child Zone presents Elasticity and Hooke's Law. Elasticity is a branch of physics which deals with the elastic properties of materials. It is the study of bodies under the influence of external force. Generally, bodies that undergo very small deformation when a very large force is applied are called rigid bodies. Bodies that resist the deformation and completely regain their original shape when the deforming force is removed are called elastic bodies. The bodies that retain their deformed shape after the external force is removed are called perfectly plastic bodies. Elasticity is the property of a material to recover its original shape or condition when the external force applied is removed. When there is a uniform force, F applied on the surface of area, then stress is defined as the force applied per unit area. The fractional change in the dimension of the body produced by the external force is known as the strain. Strain does not have any unit since it is the ratio of two physical quantities of the same kind. Hooke's law is the fundamental law of elasticity. This law was stated by Robert Hooke. The statement of Hooke's law is that, provided the strain is small, stress will be directly proportional to the strain. The ratio of stress to strain is constant when the strain is very small. In this expression, F no longer means the applied force, but rather means the equal and oppositely directed restoring force that causes elastic materials to return to their original dimensions. The constant value is called the modulus of elasticity. The Young's modulus is the measure of the resistance of a solid to the change in length. Bulk modulus is the measure of the body's resistance to the change in its volume. Rigidity modulus is the measure of the body's resistance to the change in shape. A rod has a length of L, pulled by a force of F. The amount of elongation is change in L. What is the magnitude of the force if the change in length is 4 times? We can now use the equation of Hooke's law. Since the change in length is 4 times, the magnitude of the force will be 4 times. Three springs are connected in series parallel, as shown in the figure. Spring 1, Spring 2, and Spring 3, all has constant of 200 Newton per meter. The mass of the object is 100 gram and acceleration due to gravity is 10 meter per second squared. What is the change in length of the equivalent spring? From the information, we know the object's mass and the constant of elasticity. Let's first determine the equivalent spring constant. Determine the change in length of the equivalent spring using Hooke's law. How much force is needed to pull a spring with a spring constant of 20 Newton per meter, a distance of 25 centimeters? We need this unit to match the unit in the spring constant. So convert the distance to meters. Plug these values into the Hooke's law formula. Since we're looking for the force required to pull the spring apart, we don't need the minus sign. A spring is pulled to 10 centimeters and held in place with a force of 500 Newton. What is the spring constant of the spring? The change in position is 10 centimeters. Since the units on the spring constant are newtons per meter, we need to change the distance to meters. The spring constant of this spring is 5,000 Newton per meter. A spring is stretched by 10 centimeters and has a force constant of 2 centimeters per dyne. Determine the force applied. Determine the force constant if a force of 100 Newton is stretching a spring by 0.8 meter. A nylon string has a diameter of 2 mm, pulled by a force of 100 Newton. Determine the stress. Since stress is force over area, we look for the area first. Now we calculate the stress. A cord has original length of 100 centimeters is pulled by a force. The change in length of the cord is 2 mm. Determine the strain. Since strain equals change in length over original length, we can substitute the values and solve. A string, 4 mm in diameter, has original length of 2 meter. The string is pulled by a force of 200 Newton. If the final length of the spring is 2.02 meter, determine A. Stress, B. Strain, C. Young's modulus. A metal cube of side 0.20 meter is subjected to a shearing force of 4,000 Newton. The top surface is displaced through 0.50 centimeter with respect to the bottom. Calculate the shear modulus of elasticity of the metal. What is the magnitude of the force required to stretch a 20 cm long spring, with a spring constant of 100 Newton per meter, to a length of 21 centimeters? The spring changes from a length of 20 centimeters to 21 centimeters, hence it stretches by 1 centimeter. What is the spring constant of a spring that needs a force of 3 Newton to be compressed from 40 centimeters to 35 centimeters? The change in length of spring is 5 centimeters when pulled by 20 Newton force. What is the potential energy of spring when the change in length of the spring is 10 centimeters? Now we can substitute and find the constant of spring. Springer has the original length of 60 centimeters, and spring B has the original length of 90 centimeters. Springer has constant 100 Newton per meter, spring B has constant 200 Newton per meter. The ratio of the change in length of Springer to the change in length of spring B is the ratio of the change in length of Springer to the change in length of spring B is given as For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.